First, in Project 1, we'll overview of electrical equipment. First, the goal of this lesson is to understand the functions and types of power plants and substations, understand the classification and use of electrical equipment, and master the rating parameters and the electrical primary equipment, master the symbols of electrical equipment. First, let's see the catalog. So in the first, we will learn the basic concept of power system, and in second, we will classification and application of electrical equipment. And in the third, we will learn the parameters of electrical equipment, and in the fourth, we will have a little summary of this lesson. So first, we will go through the basic concepts of power system. We can see this is some basic concept in the power system, and the functions and types of power plants here is that power plant is a plant that converts various natural energy, such as chemical energy, water energy, atomic energy, into electric energy. According to different energy use or characteristic of energy conversion, it can be divided into 4 parts. You can see in the chart here. The power plant can divide into thermal power plant, hydroelectric power plant, nuclear power plant, and new energy power generation. And now let's see what a thermal power plant is. A plant that converts chemical energy from fossil fuel such as coal, oil, natural gas, oil shale into electricity. You can see the fossil fuel go through boiler and will become heat energy and go into steam turbine and will change into mechanical energy, and then will go through alternator, and in the last will become the electrical energy. Most prime movers of thermal power plants are steam turbines, which convert heat energy into mechanical energy and drive generators to convert mechanical energy into electrical energy. Hydropower plant is a plant that converts the potential energy and kinetic energy of water into electric energy. So the hydro energy will go through hydroelectric turbine and change into mechanical energy, and also will go through alternator, finally will become electric energy. The prime mover of the hydropower station is the hydraulic turbine, which converts the hydraulic energy into mechanical energy, and then the hydraulic turbine drives the generator to convert the mechanical energy into electrical energy. Because the energy of the water is directly proportional to its flow and job, the key to hydropower generation is to concentrate a large amount of water and cause a large water level drop. And nuclear power plant is a power plant that converts the fission energy of atomic nucleus into electric energy. The fuel is mainly about uranium-235. Nuclear fuel will go into nuclear reactor. The nuclear reactor will change nuclear fuel to heat energy, and the heat energy will go through the steam turbine and to become mechanical energy. And finally, the last step is go through the alternator to change into electric energy. The power generation principle of a nuclear power plant is similar to that of thermal power plant, but the difference lies in the different source of heat energy. So here is the most used new energy power supply. We can see the wind power plant and solar power plant is what we see in our daily life, but biomass power plant and ocean power plant and geothermal power plant is not often used in our daily life, but it's a new way to have our new electric power. So now we can Now next we will learn something about function and type of substation. Substation is an electrical facility that transforms voltage, receives and distributes electric energy, controls the flow direction of power and adjusts voltage in power system. In power system, substation is the assembly point of transmission and distribution. It is classified according to the status and function of substation in power system. And we divide it into 5 parts, and the first is hub station, and second is intermediate substation, and regional substation, and enterprise substation, and fifth is terminal, or we can call it user substation. And the classification according to the substation building form and electrical equipment layout, we can divide it into 3 parts, which is indoor substation, semi-indoor substation, and outdoor substation. And we can also have some other categories. We can see according to the differences of power supply, object of substation is divided into urban substation, industrial substation, and agricultural substation. It can be divided into main substation and unattended substation according to whether there is someone on duty in the substation. According to different enclosure structure of substation, it's divided into civil substation and box substation. Now we can go through the introduction to new substation. The digital substation. Digital substation is a modern substation composed of intelligent primary equipment and network secondary equipment, which is layered on the basis of IEC 61850 communication protocol. Information sharing the interoperability between intelligent devices. Intelligent substation. Intelligent substation refers to a substation that adapts advanced, reliable, integrated, low carbon, and environment-friendly intelligent equipment automatically completes the basic functions such as information acquisition, measurement, control, protection, measurement, and monitoring with the basic requirement of digitalization of information, networking of communication platform, and standardized of information sharing of the whole station, and can realize the advanced functions such as real-time automation control, intelligent regulation, online analysis, and decision-making, and collaborative. And now let's go through some summary of this. The power plant is a plant that converts various natural energy, such as chemical energy, water energy, and atomic energy into electric energy. Substation is a place for collecting power, raising and lowering voltage, and distributing power. Now this is the chart shows how power system works. And you can see in the power plant we divided into 4 parts, which is thermal power plant, hydropower station, nuclear power plant, new energy power generation. And in transformer substation, we can divide it into 5 parts, which is hub substation, intermediate substation, regional substation, terminal substation, and enterprise substation. And of course, for the user side, we have this user side. And now in the chapter 2, we will learn the classification and the application of electrical equipment. So we can see the function and the classification of main electrical equipment. In order to meet the needs of power production, transmission, and distribution, various electrical equipment are installed in power plant and substation. It is used for starting, switching, monitoring, measuring, adjusting, protecting, switching, and stopping. Classification by voltage. We have high voltage electric equipment and low voltage electrical equipment. And with classification by function, we can classify by electrical primary equipment and electrical secondary equipment. Electrical primary equipment Electrical equipment directly involved in the production, transmission, and distribution of electric power is called primary equipment, include equipment for producing and converting electric energy. There are generators, transformators, and motors. They all work according to the principle of the electromagnetic induction. And then we have equipment for the producing and converting electric energy. We have alternator. The tag symbol is G and the graph symbol is G. You can see over here, and the picture is up over here. And effect is to convert other forms of energy into electrical energy. And we have a transformer. Transformer tag symbol is B or T. The graph symbol you can see over here. And this is the real picture in our daily life. And the effects of this is to transformation of voltage level transmission of electric energy. And we also have motor. Motor is the tag symbol is M and the graph symbol is M. The effect of it is to convert electrical energy into mechanical energy. And we also have switch gear, including circuit breaker, disconnector, and load switches. The circuit breaker, we can see the tag symbol is QF, the graph symbol is here. And the effect, it can not only turn on and off the normal load current, but also turn on and off the short circuit current. It's the switching appliance with the most important function, the most complex structure, and most perfect function. And we can see the switch gear, the isolating switch. The tag symbol is QS. The graph symbol is shown up here. The fact is it is used to isolate power supply and switch the circuit when the overhaul on or off those current circuit. No arc extinguish device. And then there we'll learn about the load switch. The load switch, the tag symbol is Q, the graph symbol is shown up here. The effect is the load switch allows the circuit to be connected and disconnected with load, but its arc extinguish capacity is limited and not enough to disconnect the short circuit current. The load switch is connected in series with the high voltage fuse, which can replace the circuit breaker. And then we'll learn about the reactor. Reactor, the tag symbol is I, the graph symbol is here. And the effect is suppress and absorb high order harmonics, limit closing in rush current, short circuit current, and operating over voltage, protect capacitor bank, improve system voltage waveform, and improve power factor of power grid. And then we will learn a bus or bus bar. And this is the tag symbol. And also the effect of bus bar is that they distribute electric energy or connect generators and transformer with power. The tag symbol is C, the graph symbol is here. The effect is compensate reactive power, improve power factor, reduce line loss, improve system voltage quality, and increase the transmission capacity of power transmission and transformation equipment. The arc suppression equipment. The arc suppression coil. Tag symbol is LA. The fact is that the fault capacitive current of the system shall be compensated to make the capacitance current of the grounding point capacitor to a smaller value of prevent arc short circuit. And also we have volt transformer. The volt transformer, the tag symbol is PT or TV. The graph symbol is up here. The fact is convert the high voltage out at the primary side into the low voltage at the secondary side. According to the transformation ratio for protection, metering, and instrument devices, isolate high voltage from electrical workers. Current transformer effect is that convert the large current at primary side current at the secondary side according to transformation ratio for the protection, metering, instrument devices. Isolate high current from electrical personal. And also we have fuse. The fuse is used widely, and the most easy way is to protect our equipment. And also we have lightning arrestor, which is used for limit the external or internal overvoltage acting on the equipment to protect the electrical equipment. And also we have insulator. Insulator is used to support and fix the current carrying conductor and insulate the current carrying conductor from the ground or between current carrying conductors with the different potentials in the devices. And also we have grounding devices. The grounding device is used to ensure the normal operation of power system called working ground, also used to protect personal safety called protecting grounding. Now this is all the electrical secondary equipment. The auxiliary equipment for monitoring, measuring, controlling, protecting, and regulating the electrical primary equipment is called secondary equipment, including measuring meter, insulator monitoring device, control the signal device, relay protection, and automated device, DC power supply equipment. And now here's the summary about this lesson. So electric equipment directly involved in the production, transmission, and distribution of electric energy is called primary equipment, include equipment for producing and converting electric energy, switchgear, and also we have current limiter, current carrying conductor, also have compensation equipment, and transformer. Also we have protective and appliance, also have insulator and device. And 3, we will learn some parameters of electrical equipment. So we have rated parameters, which means the value of characteristic quantity used to indicate the best operation state of electrical equipment under certain condition is called rated parameters. The rated parameters of various electrical equipment mainly include rated voltage, rated current, and rated capacity. And this is all the rated parameters. You can see we have these 4. And these 4 are very important. The rated voltage of electrical equipment is the voltage with the maximum economy effect during long-term normal operation, and the rated voltage is in order to realize the standardization and the serial production of electrical equipment. The state stipulates the standards voltage series. And also we have rated voltage of transformer. The rated voltage of primary winding of the step-up transformer is 5% higher than the rated voltage of the power grid. That is, it is the same as the rated voltage of the generator. Now, this chart shows the China power grid rated voltage in different situations. And here's the example to rated voltage of the grid line in the figure is 6 kilovoltage and 10 kilovoltage and 75 kilovoltage and 220 kilovoltage. You can try to write down the voltage at the outlet of the generator and on both sides of the transformer. And then we have the rated current. The rated current of the electrical equipment refers to the maximum current allowed to pass through the equipment for a time under a certain reference ambient temperature. At this time, the maximum temperature of long-term heating of this insulation and the current carrying part of the equipment will not exceed the specific allowance value. Now, the summary of this chapter is that the value of characteristic quantity used to indicate the best operation state of electrical equipment under certain conditions is called rated parameters. The rated parameters of various electrical equipment mainly include rated voltage, rated current, and rated capacity. And 4 is the summary of whole classes. You can see the summary we learn in this lesson is that first, a power plant is a plant that converts all kinds of new natural energy into electric energy. It can be divided into thermal power and power plants, hydro power plants, nuclear power plants, and new energy power plants. According to different energy use or characteristic of power energy conversion, Second is that the substation is an electrical facility that transforms voltage, receives and distributes electric energy, controls the flow, direction of power, and adjusts voltage in power system. And present, there are digital substation and intelligent substation. Electrical equipment directly involved in the production, transmission, and distribution of electric energy, and it is called primary equipment, including equipment for the production and conversion of electric energy, generator, transformer, and motor, switchgear, circuit breaker, disconnector, and load switch, and such as that. And also in the fourth, we learned the auxiliary equipment for monitoring, measuring, controlling, protecting, and regulating the electrical primary equipment is called secondary equipment, including these things. And also in the fifth point, we learned the rated parameter is that the parameter of various electrical equipment mainly include the rated voltage, rated current, and rated capacity. And thank you for your listening. Thank you for learning. This is all the lessons for today, and we'll see you next class.